Now let's talk about hybridization of orbitals in carbon. Hybridization is simply the mixing of atomic orbitals to form new identical orbitals known as hybrid orbitals. When we mix the atomic orbitals to make the hybrid, we will end up with the same exact number of orbitals we started with. For example, sp3 hybridization is formed when we mix s plus 3p atomic orbitals. We end up with 4 sp3 orbitals. For sp2 hybridization, we mix a single s and 2p orbitals. We end up with 3 sp2 hybrid orbitals and 1 unhybridized orbital. For sp hybridization, we mix a single s and p orbitals. We end up with 2 sp hybrid orbitals and 2 unhybridized orbitals. To better understand this concept of hybridization, let us explain with carbon. Carbon has an atomic number of 6. It is tetravalent. In its ground state before excitation, carbon has 2 electrons, that is 2s2, 2p1, 2p1 and 2p0. But this arrangement would only allow carbon to make 2 bonds since it has only 2 unpaired electrons. To make 4 bonds, excitation must occur. So on excitation, 1 electron moves from the 2s2 orbital to 2p z orbital, making the 2s orbital becomes the 2s1 and 2px1, 2py1, 2pz1. This is the excited state configuration of carbon. Now let's talk about sp3 hybridization in methane and ethane. Methane is CH4, carbon is the central atom, its valence electronic configurations are 2s2, 2p2. With this, it can only accommodate 2 electrons or 2 atoms of hydrogen in its ground state since it has only 2 unpaired electrons. To accommodate the 1 electron each from the 4 hydrogen atoms in order to form octet, it is first excited such that it has 4 unpaired electrons. The 1 electron each of the 4 hydrogen atoms are joined to each of the unpaired electrons. This covalent bond between carbon and hydrogen is a sigma bond. The 4 CH bond points at an angle of 109.5 degrees to each other and has a tetrahedral shape. Let's look at another example of sp3 hybridization in ethane. Ethane is C2H6. Looking at its structure, the 2 carbon atoms are joined to each other by a single bond, and each carbon is bonded to 3 other atoms of hydrogen. Carbon is the central atom. Its ground state valence electronic configuration is 2s2, 2p2. However, in its structure in ethane, each carbon is bonded by a single bond to 4 other atoms, so it must have 4 unpaired electrons. To achieve these 4 unpaired electrons needed for its bonding, it excites its 2s2 electron into the 2pz orbital. Now let's talk about sp2 hybridization in carbon atoms. It involves the mixing of one 2s orbital and two 2p orbital. Let's look at an example in Ethene. Ethene is C2H4. Looking at the diagram, it consists of two carbon atoms bonded to each other by a double bond. Each carbon atom in Ethene is connected by a single bond to two hydrogen at a double bond to another carbon atom to give an octet configuration. Carbon has a valence ground state configuration of 2s2, 2p2. For tetravalency, one electron of the 2s2 orbital is excited to the unoccupied 2p orbital. One electron each from the four hydrogen atoms pair up with the unpaired p electrons. There is one unhybridized p orbital left. This pairs up to form the pi bond. Hence, there are two bonds between the two carbon atoms of Ethene, a sigma bond and a pi bond. In summary, sp2 hybridization is trigonal planar. It has a bond angle of 120 degrees. It is present in alkanes. Now let's talk about sp hybridization in Ethine. Sp hybridization involves the mixing of one 2s orbital and one 2p orbital to form two sp hybrid orbitals. Ethine is C2H2. Looking at the diagram of Ethine, it consists of two carbon atoms bonded to each other by a triple bond. Each carbon atom in Ethine is connected by a single bond to one hydrogen and a triple bond to another carbon atom to give an octet configuration. Carbon has a valence ground state configuration of 2s2, 2p2. For tetravalency, one electron of the 2s2 orbital is excited to the unoccupied 2p orbital. One electron each from the two hydrogen atoms pair up with the unpaired p electrons. There is two unhybridized p orbital left. This pairs up to form the pi bond. Hence, there are three bonds between the two carbon atoms of Ethine. In summary, sp hybridization is linear. It has a bond angle of 180 degrees. It is present in alkynes. Now, to summarize it all, sp3 hybridization has a bond angle of 109.5 degrees. sp2 has a bond angle of 120 degrees, and sp has a bond angle of 180 degrees. The geometry of the sp3 hybridization is tetrahedral. For sp2, it is trigonal, and it is linear for the sp hybridization. sp3 hybridization has 4 sigma bonds. sp2 has 3 sigma bonds and 1 pi bond, and the sp hybridization has 2 sigma bond and 2 pi bonds. The s character in sp3 is 25%. That is, sp3 has a total of 1 s orbital and 3 p orbitals to give a total of 4 orbitals. Hence, s orbital has a ratio of 1 to 4, which is same as 25%. In sp2, s character is approximately and it is 50% in sp hybridization. sp3 hybridization is found in the compounds of alkanes, cycloalkanes, and other saturated organic compounds. sp2 is common in alkanes, carbonyls, among others, and sp hybridization is found in alkynes and all other compounds containing. It is important to note that electronegativity increases with S character. Hence, as the S character increases from 25% in sp3 hybridization to 50% in the sp hybridization, electronegativity increases. Hence, sp hybridization orbital is more electronegative than the sp2 orbital, and the sp2 orbital is more electronegative than the sp orbital.